Good day everyone, I am EXEQUIEL BILOG and I will be discussing you the first part of our thesis paper entitled Common Mode Classification Using Histogram of Oriented Gradients and Convolutional Neural Network. To start with our presentation, I will give you a brief information about our paper. First is the statement of the problem. The problem is that the conventional way of classifying mode is still a tedious process, and the accuracy of classification always depends on the knowledge and experience of microbiologists. Now, the general objective of this study is to develop a system that can capture microscopic mold images and to classify it by using histogram of oriented gradients and convolutional neural network. Then, we came up to have three specific objectives. First is to create a system that has the capability of classifying mold. Second is to implement the classifier histogram of oriented gradient and convolutional neural network. Third is to validate the accuracy of those classifiers. With that being said, this study only focuses on classifying 5 different fungi genera, which are the family of Aspergillus, Alternaria, Cladosporium, Rhizopus, and Penicillium. In addition, this system uses only a separate microscope to capture the microscopic mold images. Lastly, we, the researchers, perceive that this study will improve the conventional way to classify mold. Next is the conceptual framework of the study. For our input is the image of the mold captured from the microscope. Then it goes to a process of data pre-processing, training of the convolutional neural network, and lastly testing. For its output, it should be the classification of mold. Here is some images of our setup doing the testing of our proposed method. Now, for our gathering of training datasets, we gathered the images from these research institutes, research studies, and online datasets. The image below is an example of Aspergillus datasets. Now, the most essential part of our study is to culture the mold. So, with the help of Miss Tracy Gutierrez, she's taking masteral of microbiology in University of Santo Tomas. The isolates Penicillium and Aspergillus niger were subcultured on a petri dish. She left it for a week in room temperature, waiting it to grow and to be cultured on the petri dish. After a week, the isolates were subcultured again before performing the slide preparation. Here's some images showing a 1 week old of mold, of Penicillium mold and Aspergillus niger mold. For its week 2, after putting it on a slide, we waited for 2 to 3 weeks for the fungi to grow on the slides. Now, after 5 weeks, the the fungi. Here is the an image of fungi growth in these slides. Here is an example of microscopic images. A 5-week-old microscopic image, 5-week-old fungi in a microscopic view. The images has bubbles, so Miss Tracy said that it still need time, let's say 2 weeks to grow, to finally have fully growth cultured fungi. So after 5 it is a part of fungi. It's starting to grow on week 5. Then in final week, a fungi 7-week-old. Here is the final image, final view of final image of the fungi cultured. Here is an additional information about our fungi, which is the Aspergillus fungi and the Penicillium fungi. It is only a brief background of those fungi that has grown in our slides. Now, this part will be discussed by Mark Anthony NANOZ for the part 2 of the video 1. Thank you, and see you again.
So, I'm Mark Anthony NANOZ. I will discuss the second part of the methodology. So, our methodology is divided into 2 parts. First is culturing fungi, which was discussed by EXEQUIEL BILOG, and the other is more on computer algorithm. So, image acquisition is the first process. This is the flowchart for image acquisition. EXEQUIEL already discussed the process until slide preparation of the fungi. After that, the slide will be placed on the microscope to locate the fungi. After locating, a USB camera will be used to capture the image. Next is image processing. We have 3 methods. First is image grayscale. Grayscaling is converting color image to black and white image. There are 3 channels in color image, which are red, green, and blue, or RGB. This channel will become one called luminance or brightness. We use grayscaling to remove the complexity of the image and to lessen the computational power and time used for training the classifier. Next method is histogram of oriented gradient, or HOG. It is one of the main topic of our study. We use HOG as a feature descriptor that encodes interesting information and removes unnecessary information. Next is image rescaling. It is used to change the dimension of the image to prepare it for the training. Next is convolutional neural network, or CNN, another core topic of the study. CNN is a deep learning or machine learning algorithm. It is used for image classification or recognition based on the learning pattern of the image. Next is training of the CNN. We use TensorFlow to train the CNN. There are 2 types of TensorFlow: TensorFlow CPU and TensorFlow GPU. TensorFlow GPU trains faster than TensorFlow CPU, but it uses more computational power. We use TensorFlow CPU since our device did not meet the requirements for TensorFlow GPU. So, to cope up with the training speed of the TensorFlow GPU, we use grayscale image to lessen the complexity of the image. So, there are 120 training dataset for each class, and we have 6 classes. Alternaria, Aspergillus, Cladosporium, Penicillium, Rhizopus, and unknown. So, a total of 720 training dataset were used. There are These are parameters used in the study. They are called hyperparameters. These hyperparameters can be learned during the training period of the CNN. Table 1 shows the CNN architecture of the study. Next is testing of the CNN or classification part. Same architecture were used. There are 3 testing datasets for each class, so a total of 18 images. Results and discussion. 18 testing images were used. Out of 18, 16 were correctly classified by the CNN and 2 were incorrectly classified. Table 2 shows the result of the proposed method versus conventional method. Number 13 and 16 were the incorrectly classified. Table 3 shows the confusion matrix of testing results. Table 4 shows the statistical measures from the confusion matrix. Equation 1 is used to compute the accuracy, and equation 2 is for the precision. TP is true positive, TN is true negative, FP is false positive, FN is false negative. Conclusion: this study was able to create a system that can classify different fungi genera using histogram of oriented gradients and convolutional neural network using USB camera with more than 85% accuracy. The confusion matrix achieved an overall 96.29% accuracy. So that's all, and thank you.